BARD, AI's language and image power. The intriguing discovery that sheds light on the intricate workings of large language models, particularly focusing on GPT 3.5. Strap in as we explore the intricacies of its abilities, or perhaps limitations. But first, welcome to Tech Too Fast, where imagination meets acceleration in the tech lane. Don't forget to like, subscribe, and hit that notification bell. Now, let's dive in! The reversal curse and identifying Hugo. The intriguing phenomenon of a reversal curse has surfaced in the evaluation of GPT 3.5. When subjected to specific inputs, the model demonstrates proficiency in progressing from point A to B. However, a noticeable limitation emerges when attempting to reverse the process, revealing an asymmetry in its capabilities. This discovery has stirred conversations among researchers, introducing a nuanced perspective on the model's generalization abilities. The revelation of this asymmetry challenges prior assumptions about the model's comprehensive understanding and adaptability. Even researchers from Google DeepMind, known for their advancements in artificial intelligence, expressed surprise at the patchy nature of the model's knowledge. This newfound insight prompts a deeper exploration into the intricacies of language models, shedding light on the complexities and idiosyncrasies that shape their performance. Input-output asymmetry and patchy knowledge. The puzzle of asymmetry between input and output in language models, or LLMs, unfolds as a nuanced challenge. While moving from input to output holds a fixed meaning, the reverse direction lacks a straightforward correspondence. This asymmetry doesn't necessarily imply a deficiency in deductive logic with a context window, as evidenced by LLMs effectively solving tasks involving clues and relationships. This intricacy lies in the gradient update during training, revealing a myopic perspective that impedes backward reasoning. This sheds light on the complex dynamics of how LLMs process information and adapt to patterns. Researchers grappling with this phenomenon are delving into the underlying mechanisms, seeking to unravel the specific factors contributing to the reversal curse and refine our understanding of language models' cognitive processes. Out-of-context learning and challenges in reasoning. The intricacies of out-of-context learning in GPT 3.5 unveil a complex interplay between prediction accuracy and comprehensive reasoning. When the model undergoes training on paraphrases of facts, it demonstrates an impressive ability to predict words accurately, showcasing a proficiency that suggests a nuanced understanding of language. However, the transition from this word-level accuracy to holistic reasoning seems to encounter challenges. The myopic nature of the gradient update process comes to the forefront as a potential contributor to the model's difficulties in predicting A from B. This myopia, or short-sightedness, implies that the model's learning and adjustments during training may lack the broad context needed for effective backward reasoning. While the model excels in moving from input to output, the reverse process appears to be hindered, shedding light on the intricate dynamics of how GPT 3.5 processes information and the limitations it encounters. Researchers are now delving into the core mechanisms of out-of-context learning, aiming to unravel how GPT 3.5 forms connections and refines predictions. This exploration not only enhances our understanding of the model's inner workings, but also contributes to the broader conversation on the capabilities and constraints of language models. As the AI landscape continues to evolve, these insights become pivotal in shaping the future development and applications of artificial intelligence. But before we dive deeper into chess and beyond, memorization versus reasoning, remember to stay on the loop with Tech Too Fast. Like, subscribe, and drop us a comment to let us know your thoughts. Chess and beyond, memorization versus reasoning. The chess-playing prowess of GPT 3.5 at an ELO level of 1,800 is indeed noteworthy, showcasing its ability to engage in strategic gameplay and adhere to the rules with a high degree of accuracy. However, the question of whether GPT 3.5 has truly mastered chess or it's relying on pattern memorization remains a subject of exploration. Chess mastery typically involves a deep understanding of strategic principles, tactics, and the ability to foresee moves ahead, raising inquiries about the depth of GPT 3.5's comprehension of the game. Another intriguing dimension is the consideration of whether GPT 3.5 needs to achieve mastery in every domain, or it can leverage specialized models such as Mu-0 for specific tasks. Mu-0, developed by DeepMind, excels in reinforcement learning and planning without prior knowledge of the game rules. The synergy between models like GPT 3.5 and task-specific algorithms like Mu-0 highlights the potential for a collaborative approach in AI, where different models contribute their strengths to tackle diverse challenges. As the field of AI advances, understanding the nuances of how models specialize and collaborate becomes essential. The exploration of GPT 3.5's approach to chess and its potential collaboration with other models sheds light on the evolving landscape of artificial intelligence and the diverse strategies employed to tackle complex tasks. The challenge of multi-step reasoning. Recent findings indicate a notable gap in the systematic problem-solving capabilities of transformers, including GPT 3.5, particularly when faced with tasks requiring complex multi-step reasoning. While these models excel in linearized subgraph matching, their performance tends to falter in tasks that demand higher-order cognitive processes. This observation raises questions about the efficiency of relying solely on maximum likelihood training or MLT to cultivate genuine reasoning skills in AI models. The empirical evidence highlights a limitation in the current paradigm, emphasizing the need for advancements in AI training methodologies to address the challenges associated with intricate reasoning. Achieving true reasoning skills involves not just pattern recognition, but also the ability to infer, deduce, and synthesize information across multiple steps. The findings prompt a reconsideration for the training approaches employed in developing transformers, with an emphasis on fostering more robust and versatile reasoning abilities in AI systems. The future beyond LLMs, Mu-0 and Efficient Zero. As we ponder the future, it's essential to recognize that AI extends beyond large language models. Models like Mu-0 utilizing reinforcement learning and Monte Carlo search showcase impressive performance in domains like chess and Atari. The efficiency of models like Efficient Zero prompts the question, does GPT 3.5 need to be an all-encompassing AGI, or can it synergize with specialized models for optimal performance? Conclusion. And there you have it, the intricate world of GPT 3.5 and the nuanced challenges it faces. As we navigate the landscape of AI, it's evident that true reasoning capabilities may require more than the current trajectory of large language models. Stay tuned for further explorations into the evolving realm of artificial intelligence. Like, subscribe, and share your thoughts in the comments. Until next time, keep questioning and keep learning. Once again, this is Tech Too Fast. Don't forget to like, subscribe, and turn on the notification bell.